Hey there, welcome. In this video we look at creating objects in Java. Keywords are declaration, initialization, assignment, values, references, and finally impact on garbage collection. In this video you will see 5 ways that we can create objects, and we talk about how long they are kept in memory. As programmers, we often talk about calling a method and getting an object in return. This is a quick way to describe what is happening, but it is not very precise. Here follows a simplified and incomplete explanation for Java. We create objects because we want to achieve something. We may want to acquire data from somewhere. If we say that we have an object, we don't really have that data. Instead, we have a value that is a reference to a location in memory. And the contents of the object we are talking about can be found there, at that location in memory. A variable is a name that refers to a value, and that value is called a reference. A reference is an address to a location in memory. If we want to access an object, the variable can refer us to the correct location in memory. That is where the name reference comes from. At that location is the start of the memory space that contains everything that the object consists of. Some of these things are also references to other places in memory. When we discuss objects in Java, we also need to discuss garbage collection. I'm providing a simplified explanation here, but a better explanation can be found in the links below the video. The garbage collector frees up working memory by collecting our garbage. Objects are created all the time. At some point, our Java application might start to run out of memory. Most recently created objects can probably be considered garbage. They were created and used, but now no variable is referencing them anymore. The garbage collector will check to see if there are any references to an object. If not, the garbage collector will delete that object. The way we create objects and make them available has an effect on how much working memory can be freed up. Like I said, this is a very simplified explanation and incomplete explanation of garbage collection. Please do check the link. There's a lot of good information in there. So, let's move to the examples. Here's the first example. Here we declare that we want to hold any object of type expensive resource, and we want to refer to that object with the name A. We call this variable A because generally speaking the contents of A can vary during the lifetime of the variable. However, here we declare that this expensive resource is final. The exact expensive resource we refer to will not change, though its contents might change. After declaring A, we immediately initialize it. In other words, we immediately assign an initial value to the variable called A. We cannot assign something else to A later on because it is marked as final. Variable A is also marked as static. As a result, A exists separate from any instance of the example class. A will be initialized when this class is first used in any way. There will only be one variable A as long as this class is used anywhere. Object A cannot be garbage collected as long as this class is loaded by any class loader. This is important to realize because the object will probably end up using memory for almost the entire lifetime of the application. Here we declare and immediately initialize B. Initializing simply means assigning an initial value to the variable called B. In this case, that value is final. When we talk about the value here, we are talking about a value that refers to a particular data item. In this case, the data item is located in memory. Object B will be created when an instance of this class example is created. There will be one object B per instance of this class. Object B cannot be garbage collected as long as this instance is used anywhere. For each instance of this class, we will be taking up space in memory to store this object. We will only get space back if this instance of the example class is garbage collected. Here we declare a variable C. We don't initialize it here, it is initialized in the constructor instead. C is again final, and there will be one C per instance of example. Here we declare a variable D. We don't initialize it, instead it is assigned when the setD method is called. Each instance of the example class will have one variable D. However, variable D may not have been assigned any value. D may not be referring to an object, it may be null. A small amount of memory is required just because each instance of example has declared variable D, but other than that, variable D only has an effect on memory usage and garbage collection if it is assigned by calling setD. Finally, there is also a way to get a value from this class that is not assigned to any variable. That is what happens in the getE method. The object that we return here is created every time this method is called. There is no variable e that gets declared, initialized, or assigned. We simply instantiate an object of a specific class and return the value of the reference to that object to the caller of the getE method. Whether the result of getE can be garbage collected depends on whether the caller is storing that reference or not. Because the getE method does not use anything that belongs to an instance of the example class, we can mark getE as static. Let's call that static version getF. We don't need an instance of the example to call getF because getF is static. We can simply call example.getF method. Okay, I hope it was kind of clear and helpful. Thank you for watching.